In this video, we're going to describe the process of corrosion and explain how corrosion can be prevented. Corrosion is where a metal is gradually destroyed by reacting with substances in the environment. For example, iron can rust. The process of iron rusting is where iron reacts with oxygen and water, and this produces hydrated iron 3 oxide. Hydrated iron 3 oxide is the chemical name for rust. Here we have a block of iron. If the iron reacts with oxygen and water, it will form rust. Rust will occur on the surface of the iron, and rust is soft and crumbly. It can flake off the surface. This will leave some new surface exposed underneath the layer of rust. And this new surface can then start to rust itself. This means that all of the iron will eventually corrode through this process. You need to be able to discuss how you could use a series of experiments to prove that iron needs both oxygen and water to rust. In the first test tube, we have an iron nail in boiled water. When the water has been boiled, it removes the oxygen dissolved in the water. And we also place a layer of oil on top. This will prevent any oxygen getting into the water. In this case, the nail hasn't rusted, proving that oxygen must be needed for the nail to rust. In the second test tube, we've added an iron nail and calcium chloride. Calcium chloride will absorb any water which is in the air. This means that as the nail hasn't rusted, water must also be required for rusting. The third test tube has an iron nail with both oxygen and water present, and it has rusted, proving both oxygen and water are needed for an iron nail to rust. When aluminium reacts with oxygen, it produces aluminium oxide. It doesn't need water to corrode like iron does, just oxygen. So an aluminium block could have a layer of aluminium oxide forming on top. Aluminium oxide does not flake away. It forms a protective layer on the surface which prevents further corrosion from taking place. This is because if the top layer doesn't flake away, there is nowhere for the layer underneath to become corroded. If the top layer stays in place, the aluminium underneath can't react with the oxygen, therefore further aluminium oxide can't be produced. There are 3 methods you need to know about through which corrosion can be prevented. The first is the barrier method. And this involves painting a metal or coating it with a plastic. This provides a barrier which keeps out oxygen and water from coming into contact with the metal. This can be used on both big and small structures. It can also be decorative, as you can see from the Golden Gate Bridge in the picture. Electroplating coats iron with a layer of a different metal which isn't susceptible to corrosion. Oiling or greasing moving parts, for example a bike chain, provides a barrier to oxygen and water and prevents them coming into contact with the metal. Sacrificial protection is the second method of preventing corrosion. This involves placing a more reactive metal with the metal you want to protect. Water and oxygen will then react with the sacrificial metal instead of the less reactive metal. For example, big blocks of magnesium can be bolted onto iron or steel. This is used on a ship's hull or sometimes on iron pipes. So in the water, any oxygen present will react with the magnesium blocks rather than with the iron or steel hull instead. Galvanisation is the final method of preventing corrosion. This is where a barrier is made out of a sacrificial metal. For example, an iron object can be galvanised by spraying it with a coating of zinc. The zinc layer is firstly protective as a barrier, but if it's scratched, the zinc around the scratch works as a sacrificial metal, preventing further corrosion from taking place.